All right, for all you experienced auto techs out there, you know the deal. You're deep into a tricky diagnostic, and you're always looking for that edge to level up your game. Well, in this explainer, we're going to unlock a feature on a tool you literally use every single day that can save you a ton of time.
You know the feeling, right? We've all been there. You're running your standard voltage and resistance checks, but the numbers, they're just not making sense. Your multimeter is giving you readings that are all over the map, and you know exactly what that means. Time to drag out the scope. Now, the scope is an amazing tool, but let's be honest, it's not always a quick one. But what if there was a much faster way to get a solid answer? What if I told you there's a super powerful function that's been hiding in plain sight on your multimeter this whole time? One that's just waiting to help you nail down problems in minutes, not hours.
Okay, so this faster way, it's your multimeter's diode mode. Let's dive into what it is, and more importantly, what makes it so much better than the resistance mode we all know and love, especially when you're working on modern automotive electronics. So what is diode mode actually doing? Well, instead of just measuring resistance in ohms, it's smarter. It actively sends a little bit of steady current through a component and then measures the voltage drop across it, giving you a reading in volts. It is specifically designed to test semiconductors, which is exactly where your standard resistance mode just gets completely confused. Let's put them side by side. Resistance mode, it's great for simple stuff. But in a complex digital circuit, it gets easily fooled by things like pull-up resistors or just the general weirdness of an IC. Diode mode, on the other hand, it's like it has X-ray vision. It sees right past all that noise, letting you directly test the semiconductor junctions and get a real health report on what's happening inside that chip. And this next part, okay, this is the real aha moment. This is the secret sauce that makes the diode mode technique so unbelievably powerful for working on today's cars. This isn't just some generic electronics trick. It is tailor-made for what we do in the shop. And here's why. Almost every single input and a lot of the output pins on our sensors and ECUs have these tiny built-in protection diodes. Think of them as little bodyguards for the sensitive chips inside. They're there to protect against static electricity, ESD, by shunting any dangerous voltage safely to ground or to the supply rail. And that is the whole game. When you put your meter in diode mode and you touch a sensor pen, you're not just getting some random reading. You are performing a direct health check on that component's own internal bodyguards. A good diode gives you a predictable voltage drop. A bad one, well, that tells you something is seriously wrong inside. All right, theory's cool, but let's see how this actually plays out in the bay. We're going to walk through 2 real-world examples that you can go and apply on your very next job.
First up, a classic, a camshaft sensor. Now, this technique is a real game changer when a car has 2 of them, say one on each bank of a V-engine, because it gives you a perfect known good component to compare against, right there on the same car.
So here's the play-by-play. You hook your positive lead to battery ground, then you start probing the sensor pins. The ground pin on the sensor should be close to 0, makes sense, but the 5-volt and signal pins should read right around 0.6 volts. That's the classic voltage drop of a happy, healthy silicon diode. Then, you swap your leads and do it again. Now, that 5-volt pin might be up around 1.2 volts. The key is, any big difference between your suspect sensor and your known good one points you straight to the problem: an open, a short, or even a bad ECU.
Okay, let's switch gears to a totally different animal, an ignition driver inside the ECU. Now, these are built tough because they have to handle the massive voltage spikes from the ignition coil every time it fires. So because they're built to take a punch, these ignition drivers don't have those same little ESD protection diodes. And what that means for us is that a healthy ignition driver circuit, when you test it in diode mode, should show no connection at all. Your meter will just read OL, open line. That's your baseline. That's what a good one looks like. But if you test that driver, and instead of seeing OL, you get a reading, let's say around 1.2 volts, that's it. That's your smoking gun. It means that driver is shorted inside the ECU. You have just found a bad ECU in minutes, a diagnosis that could have easily taken an hour or more with a scope and a bunch of hassle. So you can see just how powerful this is, right? But like any truly pro-level skill, it takes a little practice to really master it. So let's talk about how you can start weaving this into your diagnostic routine safely and effectively and really build that confidence. Look, this isn't some kind of magic trick. It's a real professional skill you develop. The absolute best way to start is by confirming your findings. The first few times diode mode tells you an ECU is bad, pull out the scope and prove it to yourself.
Every time you do that, you build trust in these readings, and you develop that expert judgment to know when the measurement is solid all on its own. You know, using the diode function isn't about taking a shortcut. It's about being a smarter, more efficient diagnostician. And it really makes you wonder, what other expert-level techniques are hiding in plain sight, right there on the tools we already own? Mastery is all about that constant search for a better, smarter way.